Signs of life on Mars? NASA's discovery leaves experts amazed. The possibility of life on Mars has captured the imagination of scientists and the public alike for decades. As Earth's closest planetary neighbor, Mars has long been considered a potential candidate for harboring life due to its once water-rich environment and intriguing geological features. NASA's recent discovery has reignited the excitement surrounding the red planet, leaving experts amazed by the potential signs of life uncovered by the Perseverance rover. While Mars is now a cold, dry, and inhospitable place, new findings suggest that in the distant past, it may have been much more Earth-like and possibly alive. In this article, we explore NASA's groundbreaking discovery, the methods used to detect these signs of life, the history of Mars exploration, and the implications of finding life on Mars. The results have left scientists and space enthusiasts alike wondering, could Mars have once harbored life? And if so, what does that mean for the future of space exploration? The fascination with Mars and the search for life. For centuries, humans have been fascinated by Mars. Its reddish glow and its prominence in the night sky have made it a fixture in mythology and literature. Early astronomers such as Giovanni Schiaparelli and Percival Lowell believed they had observed canals on the Martian surface, which led to speculation that intelligent life existed on Mars. Though these observations were later disproven, the question of life on Mars persisted. The scientific community's interest in Mars as a potential home for life grew when evidence began to mount that liquid water, an essential ingredient for life as we know it, once flowed on the planet. Over the past several decades, NASA has sent a series of missions to Mars to determine whether the planet could have supported life at any point in its history. These missions have revealed a complex geological past, including signs of ancient lakes, rivers, and even vast oceans. Yet, despite the growing body of evidence that Mars was once a more hospitable world, definitive proof of life has remained elusive. Until now, the Perseverance rover, NASA's latest mission to Mars. NASA's Mars 2020 mission, centered around the Perseverance rover, represents the most ambitious attempt yet to uncover signs of past life on Mars. Launched in July 2020 and landing in Jezero crater in February 2021, Perseverance was equipped with cutting-edge technology designed to investigate Mars geology, climate, and potential for past habitability. Its primary objective is to search for biosignatures, signs of life, especially microbial life, that may be preserved in the planet's ancient rocks. Jezero crater was chosen as Perseverance's landing site because scientists believe it once hosted a large lake and river delta, making it an ideal location to search for signs of life. Over billions of years, sediment from the ancient lakebed may have trapped and preserved organic molecules or even fossilized microorganisms, providing a window into Mars' biological history. Perseverance is also tasked with collecting rock and soil samples that will eventually be returned to Earth for more detailed analysis. This sample return mission, planned in partnership with the European Space Agency, ESA, represents a major milestone in the search for extraterrestrial life, as it will allow scientists to study Martian material with state-of-the-art instruments unavailable on the rover itself. NASA's stunning discovery: organic molecules in Jezero crater. In September 2023, NASA announced a major breakthrough. Perseverance had detected complex organic molecules in rock samples taken from the floor of Jezero crater. Organic molecules, which are carbon-based compounds, are considered the building blocks of life. While they can form through abiotic, non-living processes, their presence in specific geological contexts suggests that they could be remnants of ancient biological activity. The discovery of these organic molecules is significant because it adds to the growing body of evidence that Mars once had the conditions necessary to support life. According to NASA scientists, the organic molecules found in Jezero crater are similar to those formed by living organisms on Earth. This finding does not confirm that life existed on Mars, but it raises intriguing possibilities that must be explored further. The specific types of organic molecules detected, along with their chemical structures, suggest that they may have been formed in water-rich environments, such as ancient lakes or rivers. This aligns with the geological evidence that Jezero crater was once a large lake, potentially making it a prime habitat for microbial life billions of years ago. Could there be fossilized microbes on Mars? In addition to the organic molecules, NASA scientists have identified specific rock formations in Jezero crater that resemble structures created by microbial activity on Earth. These formations, known as stromatolites, are layered mounds of sediment that are produced by colonies of microorganisms. On Earth, stromatolites are some of the oldest known evidence of life, dating back billions of years. While it is too early to say definitively whether these structures on Mars are biological in origin, their resemblance to microbial formations on Earth has left many scientists cautiously optimistic. If confirmed, the discovery of fossilized microbes on Mars would represent the first direct evidence of life beyond Earth, a discovery that would have profound implications for our understanding of the universe and the potential for life elsewhere. Challenges in confirming life on Mars. Despite the excitement surrounding these discoveries, NASA scientists have emphasized that further analysis is needed before they can conclusively say that life once existed on Mars. One of the key challenges in confirming Martian life is distinguishing between biological and non-biological processes that could produce the same chemical signatures. On Earth, organic molecules are often associated with living organisms, but they can also form through abiotic processes such as chemical reactions between water and rock. Similarly, the structures observed in Jezero crater may resemble stromatolites, but they could also be the result of purely geological processes. To address these challenges, NASA plans to conduct more detailed analysis of the rock samples collected by Perseverance. The rover is equipped with a suite of instruments, including Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, which uses ultraviolet lasers to detect and analyze organic compounds. By combining data from multiple instruments, scientists hope to build a clearer picture of the chemical and geological processes that occurred on ancient Mars. However, the most definitive analysis will come from the samples that Perseverance collects and stores for return to Earth. Once these samples are brought back to Earth, they will be subjected to a wide range of advanced tests that could confirm or refute the presence of ancient Martian life. The Mars Sample Return Mission, a new chapter in space exploration. The Mars Sample Return Mission, set to launch in the late 2020s, will mark a historic moment in space exploration. For the first time, scientists will have the opportunity to analyze Martian rocks and soil in Earth's laboratories, where they can use sophisticated equipment that is too large or complex to send to Mars. This mission, a collaboration between NASA and the European Space Agency, involves sending a lander to Mars to retrieve the samples collected by Perseverance. The samples will then be loaded onto a small rocket that will launch them into Mars orbit, where they will be intercepted by a spacecraft and returned to Earth. Once the samples are back on Earth, scientists will be able to perform a variety of tests, including isotopic analysis, to determine whether the organic molecules found in Jezero crater were formed by biological processes. These tests could provide the definitive proof that life once existed on Mars, or they could reveal that the organic molecules were produced by abiotic processes. Regardless of the outcome, the Mars Sample Return Mission represents a major leap forward in our understanding of the Red Planet and its potential for habitability. It will also pave the way for future missions, including the eventual human exploration of Mars. The implications of finding life on Mars. If NASA's discoveries on Mars ultimately lead to the confirmation of ancient life, the implications would be staggering. Such a finding would fundamentally alter our understanding of biology, the origins of life, and the likelihood of life elsewhere in the universe. First and foremost, the discovery of life on Mars would suggest that life is not unique to Earth. If life could arise on two planets within the same solar system, it would imply that life may be common throughout the cosmos, potentially existing on countless planets and moons. This discovery would also challenge our understanding of life's resilience. Mars is a harsh environment with extreme temperatures, a thin atmosphere, and high levels of radiation. Yet, if life once existed there, it would suggest that life can thrive in environments that we previously thought were too extreme. This would open up new possibilities for finding life in other extreme environments, such as the icy moons of Jupiter and Saturn, which are believed to have subsurface oceans. Philosophically and culturally, the discovery of life on Mars would force humanity to reconsider its place in the universe. For centuries, we have believed that Earth is unique in its ability to support life. If life exists on other planets, it would raise profound questions about the nature of life, consciousness, and our role in the cosmos. The future of Mars exploration. NASA's discovery has reinvigorated interest in Mars exploration and has renewed calls for human missions to the Red Planet. While robotic rovers like Perseverance have been instrumental in advancing our understanding of Mars, there are certain limitations to what they can achieve. Human explorers, with their ability to make quick decisions and perform complex tasks, could significantly accelerate the search for life on Mars. NASA and other space agencies, including SpaceX, have set their sights on sending humans to Mars in the 2030s. These missions would build on the discoveries made by Perseverance and other robotic missions, allowing astronauts to explore new regions of Mars, conduct in-depth geological studies, and search for signs of life in areas that rovers may not be able to reach. One of the key challenges of human exploration will be ensuring the safety of astronauts in Mars' harsh environment. Unlike Earth, Mars lacks a protective magnetic field and has only a thin atmosphere, which means astronauts would be exposed to higher levels of radiation. Scientists are also working to develop life support systems that can sustain humans for long periods of time on the Martian surface. In addition to scientific exploration, human missions to Mars could also lay the groundwork for future colonization efforts. As Earth's population continues to grow, some scientists and visionaries have suggested that Mars could serve as a backup planet for humanity. While this idea is still in the realm of science fiction, the technological advancements being made in space exploration are bringing it closer to reality. Conclusion: a new era in the search for life. NASA's recent discovery of organic molecules in Jezero crater has left scientists amazed and hopeful that we may be on the verge of answering one of humanity's oldest questions. Are we alone in the universe? While the findings do not yet provide definitive proof of life on Mars, they represent a significant step forward in the search for extraterrestrial life. As the Mars Sample Return mission approaches and new missions to the Red Planet are planned, the excitement surrounding Mars exploration is only growing. Whether or not life is ultimately discovered on Mars, the scientific advancements made through these missions will have far-reaching implications for our understanding of the universe and our place within it. For now, we can only wait and wonder as NASA continues to unlock the secrets of Mars, a planet that may hold the key to one of the greatest discoveries in human history. The question of life on Mars may soon be answered, and the answer could change everything we know about life, the universe, and ourselves.